So hi everyone, I welcome you once again to yet another session on the previous year question papers of GATE. So now we are going to start with a new series where we are going to discuss about this particular subject, thermodynamics. So you can find many number of questions being asked from the basics of thermodynamics and the questions related to the laws of thermodynamics. So we are going to start with the previous year question papers of GATE, and this question happened in the year GATE 1993 for mechanical. And here is the question: the first law of thermodynamics takes the form of W is equal to minus del H, where W stands for work and del H stands for change in enthalpy, right? Change in enthalpy when applied to. So your first law of thermodynamics takes this form of W is equal to minus del H when applied to which one of the following system was asked as a question. And here is the first statement, option A closed system undergoing a reversible adiabatic process. And statement B, an open system undergoing an adiabatic process with negligible changes in kinetic and potential energies. And option C, a closed system undergoing a reversible constant volume process. And option D, a closed system undergoing a reversible constant pressure process. So first of all, let me make this question very simple. So if you take your first law of thermodynamics, and you know that it can be applied in two ways. One is for a process and another one is for a cycle, right? When you try to apply the first law of thermodynamics for a process, you can say that heat supplied or heat interaction would be equal to W plus del U, where del U stands for change in internal energy, right? And similarly, when you try to apply the same first law of thermodynamics for a cycle, the summation of heat interaction should be equal to summation of work interaction, because you know that for a cycle the internal energy change is actually equal to zero, because you know that the system returns back to the original position, right? And one more thing, if you try to go for the basics of your enthalpy definition, H. So enthalpy is defined as addition of internal energy and flow work, where PV is actually called as flow work. So if you try to take a closed system is a one. A closed system is a one, which is also called as control mass, because you know that here for a closed system, heat interaction is allowed and work interaction is allowed, whereas mass is going to remain as constant, right? And similarly, it is also called as non-flow process. So there is not going to be any flow of matter either from the system to the surrounding or from the surrounding to the system, and that defines the closed system, right? Whereas on the open system, if you try to take open system is a one which allows both heat interaction and work interaction, and in addition it is also been connected with mass interaction or mass transfer, and hence it is also called as flow process, right? So I can say that closed system is a one which will be associated with internal energy, whereas an open system will be associated with more than internal energy, and that is why we coined the term enthalpy, because flow work also gets added to this, right? So clearly your work is actually is found in terms of enthalpy difference. So I can definitely say that it should be an open system. And if you try to see the option A, C, and D, everything is a closed system, right? Whereas if you go for option B, I can say that it is the only thing which has been for an open system, right? So no further analysis is needed for this particular question. So an open system, so option B is the correct answer. So hope this is clear for you guys. So let's just move on to the next question. So here's a next question. A steel ball of mass 1 kg and specific heat zero point 0.4 kilojoules per kilogram Kelvin is at a temperature of 60 degrees Celsius. It is dropped into 1 kg of water at 20 degree. The final steady state temperature of the water is dash. Question was asked in the year 1999. Option A 23.5 degrees Celsius, option B 30 degrees Celsius, and option C 35 degrees Celsius, and option D 40 degrees Celsius, right? So it's a basic thing that energy would be conserved. So try to convert the given data present in the question into a diagrammatic format so that you will be able to understand. So there is a vessel containing water, and this water is initially at a temperature of 20 degrees Celsius, right? Now there is a steel ball which is initially found to be at a temperature of 60 degree, and it is being dropped inside, right? Now I can say that the steel ball is going to give the heat. So steel is the one which is going to give the heat, whereas water is the one which is going to absorb the heat, right? So whenever you try to come across a thermodynamic question, always consider that as a conservative system, which means all the heat lost by the steel ball goes only into water and not to the surrounding, right? So this is a assumption, basic thing what you have to assume, right? So all the heat which is, or else they should have actually mentioned that in the question, but it's your duty that you should remember this, that the entire heat lost by the steel ball will now goes only to the water, right? Okay, so I can say that the heat given by steel equal to heat gained by water, and we know that the heat can be calculated as mcp delta t based upon the substance which you take. You can either use cp or cv, and in most of the thermodynamic cases we'll be dealing with gases. And when you try to deal with gases which is found to be a compressible one, you can go for cv. And for any incompressible type of substance, your cp and cv are nearly equal. And for steel ball they have just mentioned that it is specific heat, but they didn't mention as cp or cv, right? So it should be actually an incompressible one, and so you can go for c. And similarly for water, it's your duty to remember the specific heat value. For most of the cases, its value would be 4186 joules per kilogram Kelvin. So Cp of water for most of the cases, you can assume it to be 4186 joules per kilogram Kelvin, right? Always try to use the standard international unit, and you can convert even this specific heat of the steel into joules, right? So equate this and try to find out the answer. And the only thing what you have to note down in this question is, see the steel after giving the heat, its temperature drops and finally reaches a final temperature, right? Similarly, initially the water was 20 degree, and after getting the heat which has been given by the steel ball, its temperature constantly rises up, and then finally it reaches a particular temperature, right? So I can say one thing, that the steel ball and water at one point of time will reach a thermal equilibrium position, which means the temperature of both steel ball and the water would be one and the same until that this heat transfer process occurs, right? So let's make use of this particular concept to be applied in this problem to find out the answer. So as I said that heat given by steel is equal to heat gained by water, right? So since it is incompressible, you can go for the Cp value of steel, and here also incompressible, so Cp value of water, and this is mass of steel and mass of water. And if you just refer to the question, nothing has been mentioned, and yes, 1 kg of steel ball mass has been mentioned, and 1 kg of water has also been mentioned clearly. So both the values are 1, and Cp value of steel has been given. If you are trying to maintain a dimensional homogeneity, then it is fine. So if you are going for kilojoule substitution, then on the other side of the equation also you have to maintain the same kilojoule. So I have said to use 4186 as joules per kilogram Kelvin for Cp value of water. And if you try to use that in kilojoules, you can go for 4.186 or roughly 4.2. Okay. And you know that this has to be multiplied with delta T, and you know that the initial temperature of steel is much higher, which is 60 degree given in the problem, and final temperature reached by the steel would be low, because you know that after giving the heat its temperature would have been reduced, so it is minus, we don't know that temperature, so we'll keep it as TF. And similarly, heat gained by the water, we know that initially the water was at 20 degree, but after receiving the heat from the steel ball, its temperature would have increased, right? So the final temperature, again, we are going to keep it as the same TF, because you know that both steel ball and water are now going to reach the thermal equilibrium. So it would be the higher temperature minus lower temperature. So for the water case, it would be TF minus T2. Hope this is clear. And try to bring the TF terms on one side of the equation and bring all the other terms to other side of the equation. Rearrange, so I'm getting 4.6 times TF equal to 24 plus 84, which is 108. So TF would be simply 108 by 4.6, so it is coming around as 23.48 degrees Celsius. So if you just get back to the options, the nearest best option is option A. So I can say that option A is the correct answer. Hope you might have understood this and enjoyed this session. And if you have any doubts, as I usually used to say, you can just mention that in the comment section. And if you like this video, please do subscribe, review, rate, and recommend to your friends. And you can also share this link. And for any other further videos, you can check the links which has been given in the description. And you can also call for some crash course type of coaching for any PSU and other competitive exams. We'll just meet up in the next session. Thank you. Bye. Have a great day.